The deepest mysteries of space travel and the human condition. That's what we explore here. And in today's video, we want to look at the mind-bending discoveries made by the legendary Voyager 1 probe. But rather than focus on its early encounters with Jupiter and Saturn, we want to zero in on its improbable survival and startling discoveries in the remote frontier of interstellar space. It's a tale of engineering brilliance, cosmic serendipity, and uncanny discoveries that blur the line between science fiction and scientific reality. What did Carl Sagan mean when he said that we must not become so clever that we lose our humanity? And how does the discovery of the anomalous zone of space relate to his prescient quote? Let's delve deeper into the enigmatic frontier where our knowledge ends and the infinite wonders of the cosmos begin. When Voyager 1 was launched in 1977, it was just one of two probes carrying a golden record filled with sights and sounds of our world in hopes of communicating with civilizations beyond our own. But it was also carrying a symbolic message from humanity to the universe. And that message was one of peace and goodwill. We are sending greetings to intelligent life out there in the universe. We hope that wherever in the universe this message might be received, it will be understood. This was the sentiment captured in the quote by Carl Sagan, one of the most renowned astronomers of our time. Sagan believed that humanity's pursuit of knowledge and advancement should not come at the expense of our empathy and understanding of the world around us. In the midst of complex calculations and technical jargon, Sagan advocated for the importance of storytelling and making science more accessible to the public. He argued that science and religion do not need to be mutually exclusive, and that the search for extraterrestrial intelligence should not be driven by greed or conquest. Instead, it should be motivated by a genuine desire to understand our place in the universe and to seek common ground with other civilizations. But what do Carl Sagan's words have to do with the astonishing discoveries made by the Voyager 1 probe? And how does it relate to the perilous journey that this iconic spacecraft has undertaken over the past 4 decades? Well, let's find out. Let's go back to the 1970s when NASA embarked on a mission to explore the outer planets of our solar system. The Voyager 1 and 2 probes were designed to take advantage of a once-in-a-lifetime alignment of the planets that would allow them to perform a series of gravity assists to propel them to the outer solar system and beyond. This audacious plan involved a daring flyby of Jupiter and Saturn which had never been done before. But the spacecraft had to be equipped with advanced cameras, scientific instruments, and enough fuel to survive the harsh conditions of deep space for several years. This presented a significant technological challenge, but the rewards promised to be immense. If successful, the Voyagers would provide humanity with unprecedented views of the gas giants and their mysterious moons. But, as we know, the story doesn't end there. Voyager 1 has now been in space for over 45 years, and it continues to send back valuable data about the outer reaches of our solar system. It's a testament to the incredible engineering and design of the spacecraft that it's still operational after all this time. But it's also a reminder of the vastness and complexity of the universe that we inhabit. As Voyager 1 left our solar system and entered interstellar space, it carried with it the hopes and dreams of humanity. It was a symbolic gesture to reach out to the unknown and to seek out new discoveries and understanding. However, as the probe ventured further into the darkness of deep space, it began to encounter strange and unexpected phenomena that defied explanation. Scientists had predicted that interstellar space would be relatively empty and quiet, but what Voyager 1 found instead was a bustling hive of activity. Charged particles, magnetic fluctuations, and gravitational anomalies all conspired to make the journey of Voyager 1 a perilous one. But amidst these challenges, there were also extraordinary moments of wonder and discovery. The most recent of these came when Voyager 1 transmitted data that revealed the presence of an anomaly in the fabric of space-time. This unexpected discovery has sent shockwaves through the scientific community and raised profound questions about the nature of reality itself. But what exactly is this anomaly, and what does it mean for our understanding of the universe? Well, let's break it down. First off, the Voyager 1 probe has been sending back garbled signals for months. This was concerning because it suggested that the spacecraft's systems were failing and that our window into the farthest reaches of space was closing. But then something remarkable happened. The signals suddenly cleared up, revealing data that was impossible to ignore. The probe had encountered a perplexing jumble of magnetic fields, charged particles, and gravitational pulls. At first, scientists struggled to comprehend what Voyager 1 was reporting. It didn't fit with any known model of interstellar space. There was too much plasma, too much radiation, and too much unexplained energy. It was as if the spacecraft had stumbled into a previously unknown region of space. And that's when Dr. Stella Mating realized that Voyager 1 was likely experiencing something she had only seen in theory. Space-time anomalies happen when the very fabric of reality is disrupted, creating pockets of warped space where the rules of physics as we know them seem to break down. These areas can be caused by extreme gravity, intense energy, or the collision of dimensions, leading to unpredictable fluctuations in space, time, and matter. While such anomalies are typically thought to be extremely rare and short-lived, Dr. Madden believes that Voyager 1 has managed to capture a glimpse of one that defies all expectations. So, what does this anomaly tell us about the nature of the universe and the possibilities that lie beyond our own reality? Well, for starters, it suggests that our current understanding of physics is incomplete. The anomaly in question is not easily explained by existing theories of gravity, magnetism, or particle physics, which means that scientists will need to develop new models to account for what Voyager 1 has observed. But that's not all. The discovery also raises the possibility that space-time anomalies could be more common than we think, which could have profound implications for our understanding of the universe. If these areas are more prevalent, it could suggest that the fabric of reality is more fragile than we believe, opening the door to the multiverse theory and other radical ideas. But perhaps the most exciting prospect is that this anomaly could be evidence of extra-dimensional activity. The idea that there are higher dimensions beyond our own is a staple of science fiction, but it's also a serious area of research in theoretical physics. The existence of space-time anomalies could provide the first tangible evidence of these higher dimensions, leading to a revolution in our understanding of the universe. But what does all this mean for Voyager 1 and the future of space exploration? Well, the good news is that the anomaly appears to be relatively stable, which means that Voyager 1 should be able to continue transmitting data for the foreseeable future. In fact, the probe is so durable that scientists have jokingly suggested it should be given a new mission to study this anomaly in detail. But the implications go beyond just Voyager 1. This discovery suggests that future spacecraft will need to be equipped with new instruments and technology to detect and navigate space-time anomalies, which could pose both challenges and opportunities for space exploration. To understand what's happening, we need to revisit the concept of spacetime. Spacetime is a mathematical model that combines the three dimensions of space with the fourth dimension of time into a single continuum. It's the stage on which all physical events take place, from the smallest subatomic particles to the largest galaxies. But what happens when this stage is disrupted? That's what we're starting to find out thanks to Voyager 1. As Voyager 1 approached interstellar space, it began to pick up unusual signals and readings that couldn't be explained by conventional science. At first, scientists dismissed them as errors or malfunctions. But as the anomalies continued and intensified, it became clear that something was amiss. They realized that they were dealing with a phenomenon that defied their current understanding of the universe. To solve this mystery, we need to turn to the realm of theoretical physics. One of the most promising explanations for what Voyager 1 is experiencing is the concept of wormholes. Wormholes are hypothetical tunnels that connect two different points in spacetime, allowing for faster-than-light travel. While they remain purely theoretical, wormholes are a natural consequence of Einstein's equations and have been supported by observations such as the behavior of quasars and the cosmic microwave background. In fact, scientists believe that wormholes are essential for time travel to be possible. But the idea of wormholes goes beyond just a scientific curiosity. It has also captured the imagination of science fiction writers who have explored the possibilities and perils of interdimensional travel for decades. Now, we don't know if that's the case with Voyager 1, but we do know that this probe has stumbled upon something extraordinary. And whatever it is, it's definitely not of this dimension. The discovery of the anomaly has shocked and excited scientists around the world, but it's also sparked a debate about the future of space exploration. Some argue that we should continue to push forward and explore the unknown, while others urge caution and a more thorough understanding of the risks involved. But ultimately, the decision will come down to one thing: our insatiable curiosity about the universe and our desire to understand our place within it. As Voyager 1 continues to beam back data from the farthest reaches of space, we can be sure that it will continue to push the boundaries of our knowledge and challenge our understanding of the universe. Who knows what other secrets the cosmos holds, and what other discoveries await us beyond the known world? What do you think? Is Voyager 1 really encountering a wormhole or something similar? Let us know in the comments below. And don't forget to subscribe for more updates on space exploration and the search for extraterrestrial life.